Hello, students. Today we're doing Sum 4, Part 1, and it's parallel lines of proportional parts. I'm going to use 4 colored pencils today. I suggest using colored pencils because I just think it really helps, especially on these first 2. And so I'm going to use blue, green, red, and then this is purple. So if you want to grab purple, you can. And then you do need this glue in that Miss Sutter, Miss Morrell should have handed out, and we're gonna just try and glue it all in one part. So if you need to, maybe just trim a tiny bit off the top or a tiny bit off the bottom. I'm gonna just cut like literally that much off so it fits nicer. So you don't really need a scissors, but if yours fits, great. And we're gonna just try and glue it all in without cutting it, because that works. So if you need to pause the video, grab your stuff, grab your pencils. I'm going to glue this in. And I'm going to glue it on the left side today. Alright, so remember with parallel lines are 2 lines that never touch. And then proportional parts means that we can write parts that are proportional. So we can write 2 ratios to help us find a missing part and then solve that proportion, which will be great. Okay. Alright, here we go. So, our triangle proportionality theorem is where all of this is going to come from today and tomorrow. Proportionality theorem. Okay. Oh, you can't see that. There we go. Crushed it. Okay. And what that tells us is that parallel lines, if a parallel line intersects the triangle, it creates proportional measurements. So, parallel line creates proportional parts. Okay, and we're going to mark those parts that are proportional. So first off, let's start with that parallel line that we see in this first top picture. So in this top picture here, we see that we have these parallel parts. Remember, we have those arrows that tell us that they are parallel. So we know that this BE is parallel to this part here that also has that arrow. The arrows don't print very well, but just pretend they're nice little arrows. So it's parallel to CD. Okay, and because of that, there's a lot of things that we get to say, which is very exciting. Okay, we can compare the parts from one side to the other side. So I can say that AB compared to AE will be equal to CB compared to ED. So this over this equals that over that. Because these are parallel, the way that they run, it has to allow for proportional parts. Okay, but also it equals the total length. So A all the way to C is proportional to A all the way to D. So we can use those. We'll use only 2 ratios at a time to solve. But based on what we're given, we'll use different parts. Okay. So remember, 2 triangles are similar if they have 2 congruent angles. So both these triangles, if you think of them as 2 of them overlapped, they both share this inside angle. And then remember, when these are parallel, we have those corresponding angles are the same. So they end up being similar triangles, and that's what allows us to go with all of these, because those are parallel. Okay. So here we go with the first one. All right, our goal is to find the question mark. Okay, I always like to start with my variable first, and you're going to see that in the practice that you have to start with that question mark or the x. So my question mark here is this here. Okay, and I'm going to compare that to the other side, 4. And I'm going to compare that to, and we know the other two parts, so I can do part over a part. So we'll do 15. 15 is on the same side of that question mark. And then on the same side as the 4 is the 10. So I went question mark 4, 15, 10. So I'm going from this side to that side. And then we can go ahead and just solve this. And to solve this, all we have to do is undo this dividing by 4. And to undo a dividing by 4, we would multiply both sides by 4. So I get question mark equals. So that 4 and 4 undo each other. And then we're going to use our handy dandy calculator that I didn't have pulled up because I am not prepared. Alright, 15 divided by 10. And then times 4. And we get 6. So question mark equals 6. Beautiful. That's it for that example. Alright, let's go to the next one. So again, we're trying to find this question mark, this length here. So again, I'm going to start with my question mark. Doesn't matter which color if you're doing colors, but I want to compare that to the similar part on the other side. So this question mark, I'm going to compare to this 12. Okay, now on this time here, the other number I have is this 25, but 25 is this whole length. It's not just this little part. Okay, and I can't find that part because I don't know how much this is. If I knew that was like 20, I could say that's 5. If this is 15, I could say that's 10. But I don't know what this is, so I can't say what that is. So I'm just going to go with that 25. But on the other side here, I need to know that whole length. And I know it's 12 and 3, so together that would make 15. So 25 over 15. Okay. And then again, we're going to solve that equation. So today it was really about getting that set up, making sure that we're putting the parts over each other that belong there. To undo that dividing by 12, we will multiply both sides by 12. Again, that undoes that 12 there, so we're left with just question mark equals 25 divided by 15 times 12, and we get 20. So we know this is 20, which if we are asking that, then we know that's 5, because it has to make 25. So 20 and 5. Awesome. Alright, that is one big idea today. I'm going to just do this line across because we're going to do one other big idea. And that is a mid-segment, which should be pretty straightforward. Okay, so mid-segment of a triangle. We talked about mid-segments of isosceles trapezoids. Actually, just of trapezoids. But today we're going to talk about mid-segment of a triangle. Okay, and what we know about the mid-segment of a triangle is it's the line that connects the midpoints of two sides. So as you can see here, our mid-segment is this JK. And we know it's a mid-segment because it is the midpoint. So this is the same size as this, and this should have 2 there, is the same as that. So we know that this is a midpoint, and that's a midpoint. Okay, And because of that, we know that it ends up being parallel to the third side. Okay, and we see that here with those parallel and parallel. Okay. Because of all of this, it creates less proportional parts, just like how we did earlier. So this over this equals this over this, and then this all over that. But since we have these all congruent parts, like this is congruent to this and this is congruent to this, there's lots of ways we can mix and match it, and it creates for this last third part that we're able to say that's half of the parallel side. Okay, so the mid segment is half of the parallel side. So there's a couple ways we could look at this. We could say that 1/2 times FG equals that JK. Or we could think JK times 2 would give us that length of FG. Alright, so in this problem here, we're going to find a couple segments. Okay, first off, we're looking at our parallel lines. So let's start with this XZ and RT. We know that those are parallel. So XZ is parallel to RT. And we know that because it would have told us that's a mid-segment. So because of that, I know that RT is 13. And so with that RT of 13, I want to know how much is XZ. And we know the longer side, so to go from that longer to that mid-segment, we're going to just find the middle. So to find the middle, we either multiply by half or we divide by 2. And 13 divided by 2 gives us 6.5. So we know that XZ is 6.5. Alright, one more we're going to do is this XY and ST. Those ones are parallel. Okay, and what we know is we know that XY is 7. So I should be able to then find ST. And XY is that mid-segment, so that's that middle part. Oops, you couldn't see that before, sorry. So that's 7. So to get the other part, we're going to double it. So we take that mid-segment and we will multiply it by 2. So 7 times 2, which looks like XZ up there. 7 times 2 is 14. Okay, and that is it for your notes today. So after you're done with this, go ahead and open up your practice. Should be in Schoology, week 8.